All right, question 2. Question 2 says a sample of 1.24 gram of a drug containing manganese 3 salts was heated in a solution of nitric acid. The resulting solution made alkaline with ammonium hydroxide. Then excess hydrogen sulfide was bubbled through it. Given that 0.29 gram of manganese sulfide precipitate was obtained, that's after the reaction, calculate the percentage of manganese in the original drug sample, given the mass number of the various compound, of the various elements, manganese 55, sulfur 32, hydrogen 1. But I advise you know this some of the mass number of regular element because some exams may not be given the mass number. Now, first of all, I would like to break down this before we solve it down. Now, the sample, this pure sample contained, now the pure sample of the drug or the pure drug was 1.24 gram. And now we are asked to calculate the percentage of manganese in the drug sample. But before we calculate the percentage of manganese in the drug sample, we have to find the mass of manganese in the drug. Manganese, which we don't know. And I think that's what we are going to, that's what we're going to solve in the question. When we get the mass of manganese, we will then be able to calculate the percentage of manganese in the pure drug sample. Now, during the process of the reaction, before the reaction took place, it was the manganese, the drug was heated with a solution of nitric acid to ensure that to dissociate manganese as a free ion in the compound, to ensure that manganese is dissociated as a free ion. And also it was made alkaline with NOH because it is actually reacting with hydrogen sulfide, which is which is acidic. So that's the function of nitric acid and alkaline ammonium hydroxide in the reaction. Nitric acid helps to dissociate the manganese ion, to remove it to be sold so that to be able to participate in the reaction. While ammonium hydroxide made it alkaline because it is actually reacting with a um, with a sulfide which is acidic. So we'll go back to the we'll go to the stoichiometric reaction. Now they said manganese 3 salts is directly reacting with hydrogen sulfide. I told you the function of this. The function of this is to dissociate manganese as a free ion. To dissociate manganese as a free ion in the reaction in the drug. And this is to ensure that the solution is alkaline to react with an acidic sulfide. So manganese is reacting with a sulfide to form manganese and hydrogen. But this equation is not complete. We have manganese as 2 year, we have manganese as 1 year. So we have 2 year. Okay, we have sulfide as 3 year, we have sulfide as 1 year. We complete it 3. So we have hydrogen as 6 here, and we have hydrogen, only hydrogen here. So that's 6H plus. So this is perfectly balanced. Now, during the course of the reaction, they said in this reaction, a sulfide was produced. This is manganese sulfide. Manganese sulfide. They say it was produced, and they gave us the gram of it being produced. That's 0.29 gram. So this is 0.29 gram. Now, according to the equation, looking at this equation, 2 moles of manganese gave birth or give rise or produced 1 mole of manganese sulfide. So we'll therefore say 2 mole of manganese give 1 mole of manganese sulfide. And remember, a mole contains the particular mass of the exact mass of that compound, but 2 moles will be multiplied by 2. So 2 mole of manganese, since manganese is 55, 2 mole of manganese will be 2 times 55 gram of manganese, give rise to 1 mole of manganese will be We have to find the mass number of this. That's 1 times the mass number of this. We have 2 manganese. 2 times 55 plus 3 times sulfide is what? 32. So N to S3. So calculating this, 2 times 55 is 110 gram of manganese ion. Will give, now let's calculate this. The mass number of this we're calculating, that's 206 gram. You times this, 1 times, this gives 206, 206. 1 times 206, 206, 206 gram of manganese sulfide. Now, we've gotten that since 110 gram of manganese ion will give 206 gram of manganese sulfide. Now, 0.29 gram from the reaction will give what? That's the particular, the exact amount of manganese, the pure manganese in the solution. That's the pure mass. That's what we are looking for. Will give what? That's X, because multiply. Then we have 206 times X is equals to 110 times 0.29. Then X becomes 110 times 0.29 divided by 206. So I have 110 times 0.29. So 110 times 0.29 divided by 206. We have 0.154. I'll approximate it to 3 decimal places. That is 0.155 gram of manganese ion. So that's our X. So for us to calculate the percentage now, the percentage will be mass of manganese ion over mass of pure drug times 100 over 1. So the percentage of manganese in the original sample will be 0.155 gram divided by 1 point, what's the pure mass of pure drug? 1.24. 1.24 gram times 100 over 1. So we have 0.155 divided by 1.24 times 100. So we have 12.5%. So the percentage of manganese in the original sample is 12.5%.